Hi guys, this is Jango Coder. If you're new to programming, you must have heard at some point that programming is for geeks or nerds. Well, I'm here to prove it wrong, and you'll fall in love with programming by the end of this video. The beautiful thing about learning how to code is that all programming languages follow the same basic structure of variables, types, operators, input and output, conditional statements, loops, arrays, methods, etc., regardless of what the programming language is. Hence, if you have a very solid understanding of these basic concepts that will be discussed in this video, then learning these programming languages will become just a matter of learning their syntax and you're good to go. I love to teach with real life illustrations because it has a way of adding a lot of imagination and fun to an otherwise complex and abstract topic. We all go to the store or the market, right? So I want you guys to imagine the whole concept of going shopping as the process of writing a computer program. The first step is to create a new project and give it a name, which in this case is going to be shopping. After naming the program, let's talk about how this shopping is going to happen. First, we need to figure out what kind of store we're going to, which depends on what we intend buying. Okay, it can be groceries, or it can be clothes, or it can be sporting goods. Okay, in a similar way in programming, we need to decide what kind of program we want to write, which depends on what our input and output is going to look like. And this brings us to variables and constants. Your input and output are going to be made up of variables and constants of different types. The basic types we'll encounter in almost all programming languages are the integers, the long, the float, the double, the char, the string, and the bool. Okay, ints and longs are whole numbers. The long is of a larger size than the int, and it's used for very large numbers. Float and double, they deal with decimal numbers. Where the float stores 6 to 7 decimal digits, the double stores much longer decimals, up to 15 decimal digits. Then the bool, they are for storing true or false values, which are the results of conditional statements. The char stores single alphabet, while the string stores alphabets as well as words and sentences, etc. Some stores, like if you go to the mall, for example, you can have all the items in one place, all right? So, same way, a program can make use of all variable types. You can use any text editor to follow along. This is Visual Studio, but it's just a text document. We can have the following variable declarations. We can have that int my int is equal to 5, and this is an integer, which is also a whole number. Next, we can have double my double is equal to 5.99d, and this is a floating point number. Next, we have char my char is equal to d. This is a character. Next one, we can have bool my bool is equal to true, and this one is a boolean. And lastly, we can have string my string is equal to hello world, and this is a string. If we are to do the same for our shopping, then we would have instead fruit Jack's fruit is equal to apple, clothes Jill's clothes is equal to a dress. This is just for illustration purposes. In our shopping scenario, the types would be of type fruits and type clothes. For type fruits, we have an apple, which is Jack's fruit. This is how we want to identify the apple. And Jill's clothes, which is a dress. The first part is the type. It must be written correctly with no typos. The next is the name that we choose for our variable, which can be anything we want to call it. Then the assignment operator, which is a single equal sign that we're going to discuss in the next topic. And finally, the value for the variable. The value must be of the same as the type. You cannot come here and have a dress. Because a dress is not a fruit. If you have the type fruit, you can have a banana here or a pineapple, but you cannot have a shoe or a ball here. No. Here it must be a fruit, okay? And the same way here, you cannot have a banana here. No. Here has to be either a shirt or a blouse or any clothing items. Okay, the same way if you have type int here, make sure the value here is an int. Okay, same way if you have a char here, make sure that the value here is a char. All right, otherwise you have to do something called casting. Some languages like Python allows you to declare variables without specifying the type. Hence, in Python, you can simply do something like my int equal to 5. Okay, Okay, we have named our program and declared our variables and constants. The next thing we do before shopping is to write a list of all the items we'll be buying, their prices, the total amount we're budgeting, the total amount our list will cost. If it is more or less than the budget, then we make necessary adjustments by removing or adding items respectively. Which brings us to our next topic, operators. In programming, operators are special symbols or keywords that perform specific operations on one or more operands. These are the basic operators that are common when writing code. We have the assignment operator, which is a single equal sign that assigns a value to a variable. In our previous examples, we can see that each of these assign the value 5 to my int using the assignment operator. And in this one, we assign this value to this variable, okay? And so on and so forth. Hence, the assignment operator is used to assign a value to a variable. Next is the arithmetic operator. Arithmetic operators perform mathematical calculations. The examples of arithmetic operators include the plus, the minus, the multiplication, and the division. We can have apple is equal to 5, shoes is equal to 10, discount is equal to 5, quantity is equal to 2. And then if we want to calculate the total cost, it's going to be equal to apple plus shoes. Then we subtract discount and we multiply it by the quantity. Okay, now notice that we didn't use numbers. We didn't use 5, 10, 5, and 2 in this calculation. We instead used the variable names because if you have like 10 places where you used apple, and then all of a sudden you don't want apple to be 5 anymore, but you want apple to now be 7, okay? If you used 5 for apple in your code, you have to go everywhere you had that 5 to change it to 7. But if you had used apple instead, all you have to do is just come here and change it to 7. And then everywhere you use apple in your code, will automatically change to 7 instead. Next is comparison operators. They compare two values and return a Boolean result which is true or false. Similar to comparing prices, examples are the double equal sign, the not equal sign, which is the exclamation point and the equal sign, the greater than, the less than, greater than or equal, and the less than or equal. Note that the double equal sign and the single equal sign are not the same. They have different purposes. While the single one is an assignment operator, the double one is to check if a variable is equal to another variable, and it's going to give you a true or false value. We can say shoes is equal to apple. It's going to return false because 10, which is the value of shoes, is not equal to 5. And next we can have discount is less than shoes. This is going to be true because 5 is less than the value of shoes is 10. So this is true. We can have that quantity is greater than apple. And let's see. Is that true or false? It's false because 2 is not greater than 5. Quantity is 2 and 2 is not greater than 7. Let's have that. Quantity is less than or equal to apple. Okay, so we all know that quantity is not equal to apple, right? In this part, quantity is not equal to apple, but quantity is less than apple, okay? And because this is less than or equal to, if one condition is true, then this whole statement evaluates to true. It's either less than or equals, then it's true. And because quantity, which is of value 2, is less than apple, which is of value 7, this is going to be true. Okay, let's see one more example. Let's say discount is greater than or equal to apple or shoes. Okay, is this true or false? Let's see. Is discount greater than shoes? Discount is 5, shoes is 10. So discount is not greater than shoes. So the first one is false. Is discount equal to shoes? Discount is 5 and shoes is 10. So discount is neither greater than shoes nor equal to shoes. No condition at all is true here. False because none of the conditions are true. Okay, now let's talk about the logical operators. The logical operators combine multiple conditions just similar to what we had in the greater than or equal sign. The logical operators combine multiple conditions and return a Boolean result. We have the AND operator, which gives a true value only if all the conditions are true, while the OR operator gives a true value if any condition at all is true. The NOT operator simply negates all conditions. The following make up the IO components of our code. We have the input, we have the processing, we have the output, and we have the feedback loop. In software development, input refers to the data or information provided to the software for processing, which in our shopping scenario will correspond to the list of items to buy, credit cards, coupons, etc. Processing represents the action taken by the software in response to the input. And this processing is usually done by algorithms, functions, and other components that handle the input data. In the case of shopping, the processing will involve going to the checkout and scanning the purchased items, either by yourself, self-checkout, or by the store attendant. Output in software development refers to the results or responses generated by the software after processing the input. And similar to the item that we purchased to the store, that would be your output in our shopping scenario. There is often a feedback loop that occurs between the output and the next input. This feedback loop is crucial in software development because it helps in improving the software's performance and user experience over time. And in our shopping scenario, this feedback loop would be similar to you as the customer reviewing the items received and providing feedback, making further requests if needed, or taking the item back to the store for a return or replacement if it was not satisfactory. Let's talk about conditional statements. They are used to make decisions based on certain conditions. The conditional statements that we'll be discussing about are the if statement, the if-else statement, and the if-elseif-else statement. The if statement is the foundation of conditional statements. It's like making a decision based on a single condition. If the store has fresh bread, I will buy it. If the condition, which is the fresh bread availability, is true, then we put the bread in the cart. Next is the if-else statement. The if-else statement is an extension of the if statement. It allows you to make a decision based on two possible outcomes of a condition, true or false. If the store has fresh bread, I'll buy it. Otherwise, I'll buy bagels. If the condition, which is fresh bread availability, is true, we put the bread in our cart. Otherwise, we go for bagel. Next is the if-elseif-else statement. This allows you to handle multiple conditions and decide based on various possibilities. If the store has fresh bread, I'll buy it. This is the first condition, and this is the first action if the first condition is true. Else, if the store has croissants, I'll buy it. Again, this is the second condition, and this action is taken if the first action is false, the first condition is false, and the second condition is true. Else, I'll go home. The else statement here is considered when all other conditions have failed. What does it mean to look through something? It simply means going from start to finish, then back to start again, over and over again. In programming, loops allow the repetition of a certain block of code multiple times until a specific condition is met. Now, there are several types of loops, but two main types from which other loops are derived are the while loop and the for loop. Let's imagine coming to the store with a very long list of items to buy without knowing how long it will take to get all the items. Some items might not be available and we might have to wait till they replace it, okay? We just know that we came to the store by 10 a.m., for example, and we're done only when we have gotten all the items on our list, which can be by 12 noon or by 6 p.m., depending on when we finish. Hence, the store in this case is a while, and we keep going in and out of the different aisles, picking up items until we exhaust our list, okay? Here, our ending condition is getting all our items. Once that condition is true, then it's time to leave the store. Same way in programming, the code block inside a while loop is executed repeatedly as long as the specified condition remains true. We exit the loop when the condition no longer applies or becomes false. The while loop would look like this. If we have a shopping list, then we can have while shopping list. While shopping list is not empty, get next item in the list. Okay, so you can see with the while loop, you have the condition in the bracket, which is our shopping list not being empty. And while this condition is true, we're going to get the next item and repeat the whole process. Repeat. Okay. Get next item on the list. We check if our shopping list is not empty. We get next item. Repeat. Check if shopping list is not empty. Get next item. And then once we check our shopping list and we find out that it's empty, we exit. Exit the store. Okay. Now let's take a look at the for loop. Again, let's imagine we came to the store with our list of items like before. But this time, we know exactly how long we want to spend at the store. We came by 10 a.m. like before, but we would like to leave by 11 a.m. We just have 1 hour scheduled for this shopping. Okay, so we start our timer and we start going in and out of the house in loops. We're working very, very fast so we can meet up with our timer and get as much items as possible. And as soon as the timer is up, we leave the store. The store in this case acts as a for loop because we know exactly when we want the loop to end and leave the store. In programming, a for loop is used to iterate over a sequence such as a list and execute the code block repeatedly for a specific number of times. Okay? We know exactly the amount of iterations that we want to perform. And back to our IDE, we still have our shopping list as before, but this time around we have two extra variables which we are going to call start time is equal to 10 a.m. and we have the end time equal to 11 a.m. Okay, and then our for loop is going to look like for timer equal to start time, timer less than or equal to end time, increment timer. Okay, and then inside our for loop we check another condition if, so this is an if statement, there is no else, just an if statement. If shopping list is empty, we want to leave the store. Okay, otherwise get next item on the list. Okay, so what exactly is going on here? First of all, we want to set our timer to start when we enter the store. Okay, so our timer starts at the start time, which is the time at which we enter the store. Okay, then we have our ending condition, which is satisfied once the timer is greater than the end time. Okay, our ending condition is when the timer is greater than the end time, which is 11 o'clock. So as long as the timer remains less than or equal to the end time, we are still going to get next item on the list. Okay, and then this increment timer is kind of like countdown. It's our timer counting down, and this ensures that our loop does not run infinitely. Okay, then when we come inside the loop, we're still checking to see if our shopping list is empty, because if we finish getting all the items in our shopping list before our timer runs out, we should still leave the store. Okay, so this statement is checking to see that if the shopping list is already empty, we leave the store. Otherwise, just continue getting next item on the list until the timer runs out. Okay, so this is a summary of how the for loop functions. Next, we'll talk about arrays. And back to shopping, we can have a shopping cart or multiple shopping carts that can hold several items. We can decide to have one cart per item, maybe one for meat, one for fruits and veggies, one for supplies, etc. Okay? Or we can have all different items in one cart. This shopping cart is similar to an array in programming. An array is a data structure that allows you to store multiple elements of the same types or multiple types. We can declare our array by simply saying shopping cart. So this square bracket is what signifies an array. Some other programming languages will have them as this, or some others you have to say new array and you specify the size of the array inside. Okay, so it depends on whichever syntax that the programming language that you want to learn is using. And next we can add items to our array by saying shopping cart 0 is equal to milk. This is the first item in our array. When we first declare this array, it's going to be empty, just like getting an empty shopping cart. And then we start adding items. The first item is going to be milk. We can add a second item, which we can call bread. Okay. We can have another one, the third item, that we can call juice. Let's have egg before juice. And finally, we can have juice as the fourth item. Okay, now notice that the first item is 0 instead of 1. The second item is 1 instead of 2. The third item is 2 instead of 3. And the fourth item is 3 instead of 4. Okay, this is because when you are index an array, the index starts from 0 and ends at n minus 1, where n is the total number of items in your array. Hence, index 0 is the first item, index 1 is the second item, index 2 is the third item, and index 3 is the fourth item, and so on and so forth. Third item, fourth item. Okay. Lastly, we're going to talk about methods. And this time around, let's imagine we came to the store with our kids. And instead of going around looking for all the items in the list ourselves, we delegate each item on the list to each child. Once they find it, they return it to us at the checkout for processing. This is exactly what methods are used for in programming. They are code blocks that perform specific operations and are reusable procedures that allows us to encapsulate functionality and avoid duplication of code. Okay. If we come back to our editor, we can have a main program Okay, every project will always have a main program that is going to run all the program components. So if in our main program we have a list of items, first of all, we write our list, write a list of items, okay? And our list is going to be a simple array that is a simple array to contain all the things we want to buy. Next, we have our while loop. While shopping list is not empty, okay? Want to look for milk. Add milk to shopping cart. Take milk to checkout. Now note that in a real life scenario, we wouldn't necessarily be taking each item to checkout as we find them, but for the purpose of this illustration, let's just assume that each item we find, we take it to checkout. And finally, we take juice to checkout. Okay, and once we have finished getting all the items, we exit the store. If we are to use methods in this our program, instead of going ourselves to find all these items, we can send the kids and have them call them back to bring the items to us, which is equivalent to what we call method call in programming. And in this case, we can have a method that we can call getMilk. And inside this method, it's going to do exactly all the things here. Okay, so this is what our getMilk method is going to do. And back here, instead of doing all of this, we can simply say getMilk. Okay, and this is going to be return milk to checkout because every method has a return type. And this return type is going to be whatever that the method is supposed to return. So this getMilk method is supposed to return a milk. So the return type is type milk. Okay. A return type can also be void or a boolean. If you, for example, told your kids to go check if there is milk, they are not to return the milk to you. They are only going to come back and tell you, yes, there is milk, or false, there is no milk. In that case, that method, the return type is of type boolean. Or let's say, for example, you just told them to go look around and see whatever they want in the store and then keep that in mind. Okay, in that case, they're not returning anything to you. The return type is void. Okay, so the function, the methods can have a void return type when they are not to return anything, or they can have a specific type, whether it's an int or a string or a boolean or a double. All of these can be the different return types that a method can return. And we can do the same that we did for getMilk. We can do it for the bread, in which case we simply come here and say and call the getBread method. Okay. And we can do the same for the juice. And here we can call the getJuice method. And for each of those, they will simply return milk, or they will return bread to checkout, or return juice. So the same exact thing, but for get bread, in which case it's all going to be bread, 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 or we do it for juice, in which case it's just going to be juice, juice, juice. Okay, so we can see now that methods are a very crucial and powerful aspect of programming in organizing and managing code. Okay, they allow you to break down complex operations into smaller and manageable parts, thereby making your code more modular, readable, and reusable. If you can understand the delegation of tasks, delegation of items in our shopping scenario, it will help you to understand the essence of programming, essence of methods in programming, which is delegating operations to specialized, highly specialized functions, which is going to promote code efficiency and facilitate code maintenance. I hope this was helpful to you. Don't forget to like and subscribe, and you are going to see more courses and more tutorials coming soon.